So yesterday we have looked at normal distribution, right? Sampling distribution by using normal distribution. So we know that when we take some sample from normal population, the sample will be also normal, right? And then another definition from central limit theorem, it says that when the sample size is more than 30, or basically sample size large enough, so the distribution is approaching normal distribution, right? So that's one from yesterday. So today we're going to look at normal approximation for discrete random variable, right? Which is normal binomial distribution and Poisson distribution, right? So now let's look at this slide. Under certain circumstances, the normal distribution can be used as an approximation to binomial problem. So still remember, what is the properties of binomial experiment? Two outcomes. The probability of success should be consistent every trial. Each trial should be independent, and we should have n trial. So that is the properties of binomial distribution, right? So by approximation method, right, we can reduce the work of calculation, right, in finding the probability, right? So the central limit theorem also can be used to approximate the probabilities for some discrete random variables when the exact probability are tedious to calculate. So this is from discrete random variable to normal distribution. So when we have very large calculation in discrete, so we can use normal approximation to approximate the probability, right? Of course, when you want to convert from discrete random variable to continuous random variable, we need to apply correction for continuity, right? Correction for continuity. It's a correction employed when continuous distribution is used to approximate the discrete random variable, right? So continuity correction or correction for continuity is used when you want to convert discrete random variable to continuous random variable, right? So based on Laplace theorem, right, provide there is a continuous curve approximating the histogram where the area of rectangles are representing the probability associated with the discrete random variable x. So basically, Laplace suggests that when you want to convert to continuous random variable or continuous distribution, you need to add 0.5 or minus 0.5 for every probability point, right? So this adding by 0.5 and minus 0.5 is called as continuity correction, right? So now, as we have learned yesterday, the normal central limit theorem can be applied when the sample size is large enough, or sample size is approaching to infinity, right? So when you have a large number of trial in binomial distribution, right? So we can approximate to normal distribution when by replacing mu equal to NP and variance equal to NPQ. So it's still using the standard normal distribution, which is Z equal to X minus mu divided by sigma, right? For binomial distribution, let's say X is having a binomial distribution with N parameter and P. So the mean for X will be equal to NP, right? So remember, and the variance of X is equal to NPQ. So we just replace the value of mean to NP and variance to NPQ, right? So this one should be square root of NPQ lah. Okay, right? So back to Laplace theorem, it suggests that to convert from discrete random variable to continuous, we need to add 0.5 and minus 0.5. So this is the rule of thumb. When we want to find the probability of x equal to a in a binomial or any discrete and a variable, so we need to minus 0.5 and plus 0.5. Right? Okay, this is the table. So when we want to find x more than or equal to a, so we just minus 0.5. More than a plus 0.5, less than or equal to plus 0.5, less than minus 0.5. Right? Okay. Right. So to convert binomial to normal distribution, there is some rule that need to fulfill, which is NP more than 5 and NQ more than 5. So when the number of trial multiplied with the probability of success more than 5 and NQ more than 5, then we can apply correction approximation method, right? A normal approximation method. Right, this is two formula. We have formula number 1 and formula number 2. You can choose either one, but I think the second one will be easiest to calculate. Right. So this is rule of thumb of normal approximation to binomial distribution. Right. So if this condition met for binomial problem, then we can apply normal approximation. Right. To apply normal approximation, we're going to use correction for continuity, right, by adding 0.5 or minus 0.5. Then we convert it to standard normal distribution, which is x minus mu divided by sigma, or this one should be equal to x minus np divided by square root of npq. Right? Okay, clear, right? So now let's look at example number 15. So in example number 15, Boeing 757 flying certain route that configured to have 168 economy class seat. So experience has shown that only 90% of all ticket holder will actually show up. Right? So they're going to be two outcome, show or not show lah. Right? So probability of show up is 0.90, and knowing that, suppose an airline sells 178 tickets for 168 tickets, seats. So we have n equal to 178. Right. So what is the probability that not everyone who arrive at the gate on the time can be accommodated? Means that we want to find the probability of 169 more than 168, right? So until 178. Right. So this is the probability that we want to find. So to calculate this, we can also use normal calculation by normal binomial distribution calculation. But if you use normal approximation, it will be more easier to calculate and find the probability lah. So let's check the condition NP is equal to 0.90 multiplied with 178. So this one should be equal to how much? 0.9 multiplied with 178, 100, take 0.2. NQ is 0.1 multiplied with 178, 17.8. So based on the rule of thumb, right? So to use normal approximation, these two values should be more than 5, right? Must be these two lah, right? Together. It cannot be either one. Right. So since NP and NQ more than 5, apply normal approximation. Right? So to apply normal approximation for this probability value, we need to convert it to continuous by applying continuity for correction. Correction for continuity correction. So this one should be 100 probability of 169 minus 0.5 until 178 plus 0.5. So this one should be 100 probability of 168.5. This is 178.5. Right? Then we convert this probability to standard normal distribution. The standard normal distribution Z equal to X minus NP divided by square root of NPQ. So our NP is equal to 160.2. NPQ is equal to 0.9 multiplied with 0.1 multiplied with 178. So this one should be 19. $16.02, right? So we plug into the formula, probability of 168.5 minus 160.2 divided by the square root of 16.02. This is Z. This is 178.5, 160.2 divided by square root of 16.02. So this one should be probability of 2.07 until 4.57, right? So refer to the statistical table. It should be probability of Z less than 4.57 minus probability of Z less than 2.07. So this one should be equal to 0.0192. So you already understand how to look at the read the table, statistical table, right? Okay, good. Okay. So first, we need to make sure the statement, the problem is binomial problem. Then we check the requirement to convert to use normal approximation. NP and NQ should be more than 5. When the condition is met, then we apply continuity correction by adding 0.5 and minus 0.5. We convert to Z distribution, standard normal distribution, and calculate the value. Right? Okay? Done? You don't forget to sign in your attendance. Or later after class, you can take your test and quiz. All right, done. Let's look at example number 16. So example number 16, it says that it is given that 40% of the population support Gamboj Party, 150 members of the population are selected at random. Use suitable approximation method as approximation to find probability that more than 55 out of 150. Right. So we have two conditions here, two outcomes, support or not support. Probability of support is 0.40. And what is the value of trial? N should be equal to 150. So we have binomial problem. So the question asks us to use a suitable approximation method, right? So let's check for NP equal to 0.4 multiplied with 150. So this one should be 60, right? And Q 0.6, 150. So this one should be 90. So since NP and NQ more than 5, so we use normal approximation, right? Normal approximation method. So the probability that we want to find is probability of X more than 55, right? So by look at the table, more than 50, more than A should be plus 0.5. Right, so it should be probability of X more than 55.5. Right. So this we apply continuity correction. Right. Simple, right? This one. Just remember the step from binomial, check requirement. Yes. Not given. Next, we convert to Z distribution, probability of Z more than 55.5 minus NP is equal to 60 divided by NPQ 0. 36. So it should be square root of 36. So this one is probability of Z more than negative 0.75. So this one should be 1 minus probability of Z less than negative 0.75. You should get 0.7734. So for next week class, right, on 30th June, I will be in class. But if you are here, then you can come to the class. Kalau tak, kita online saja. Right, I will do both lah, online and in class, face to face. Hybrid lah. Tak, Hari Raya sini. Okay? Right, done this one? Basically, this topic very simple. From binomial, identify the problem, the condition NP and Q more than 5. When it's satisfied, then convert to continuity correction, apply Z distribution. Right? Okay. So now let's look at example number 17. How many examples do we have? 17, 18, 19. Okay. 17. Right. So this is a simple example. Can you do it by yourself? Yeah. Tell me the answer. 0.2483 dapat? Yang lain sama? 0.283, 0.2483. Mine is different. Maybe mine salah. Zero point 2061. 0.20461. Okay. Right. Now let's look at this one. So we have two conditions: claim, not cheat, and cheat. So probability of success is 0.65 and is equal to 200. Yeah. So NP is equal to 130, right? And Q 70. So both are more than 5. So probability that we want to find is probability Y less than 125. Right, so since we have binomial and meet the requirement NP and Q more than 5, we use continuity correction. Probability of Y less than 125 minus 0.5, right? So 124.5. So this one, probability of Z less than 124.5 minus 130 divided by NPQ is 45.5, right? 45.5. So this one should be probability of Z less than negative 0.82. So the probability is less than negative 0.82 is equal to 0.2061. Right? Is it? Yeah, 20861, right? Okay. So example number 17, 18, 19, I think you can do by yourself, right? Okay. So let's look at example number 20. Let's practice how to convert the they apply continuity correction. Right? Let's look at the table. If you want to find the probability of x less than or equal to 3, more than less than or equal to 3, and inclusive 3 and 9, so it should be probability of 3 minus 0.5. This is x. Kejap. The proper x. This is 9 plus 0.5. So this one, probability of 3 plus 0.5 and 9 minus 0.5. So this one, probability of 10 plus 0.5, 24 plus 0.5. Right. And this one, probability of 2 inclusive less than minus 0.5, 8 minus 0.5. So more than 24 plus 25. So x more than 24.5. So I think 24 plus 0.5. Right. This one more inclusive minus, right? 76 minus 0.5. So again, benda yang sama. So this is minus 0.5. So x less than 109 minus 0.5. This one should be plus 45 plus 0.5. So if equality, so we have two sides, right? So minus and plus. So for 67 minus 0.5 and 67 plus 0.5. Same goes to 20 lah. Right? So I hope you get a clear picture about continuity correction. Okay? So let's look at the last example before we go to Poisson approximation. Atas lagi, okay. Done? Sudah? Right? So let's look at example number 21. I think 21 should be easy. Easy? Can you do it now? So this is a binomial problem, right? So probability of success 0.35 n equal to 400. Let's check the assumption, the requirement, NP equal to 400 multiplied with 0.5 is 140. And Q right, fewer than 120. What is the answer? 0.0. All right, very good. So this is 0.0158. So the second one. So this is probability of x less than 120. So this one, probability of x between 125 at most, inclusive, 132. So what is the answer? Belum lagi. So this one should be minus and plus, right? Zero point 1622. Okay. Mine is 0.1638. 1622. Okay lah. So if you take two decimal place, it should be 1622 lah, right? So then for numbers, for C, probability of x more than 160. So this one you need to plus 0.5 and find the probability value. This one is 0.0158, right? Okay, good. Boleh dapat A dah. Right? Okay, everybody done? Right. Sudah? If you're done, then we can move to the next question, which is last question for binomial distribution. So you all very fast, huh? Bagus, huh? So now let's look at example number 22, which is last example for binomial approximation. So garden short cell polyanthus plant in box. So each box contains same number of plant. The number of plant per box which produce yellow flower has binomial distribution with mean equal to 11, variance equal to 4.95. So X is having a binomial distribution and we don't know, and P also don't know. But we do know NP equal to 11 and PQ equal to 4.95. Right. So we want to find the number of plant per box. So based on the information that we have, NP equal to 11 and PQ 4.95. So this is number one. Number two. So we include NP into second equation. So 11Q equal to 4.95. So Q will be 0.45. So from here, P will be 0.55. Right? So when we know since we know already the value of P, so N multiplied with 0.55 equal to 11 and equal to 20. Right? So this is for A1. Okay. For A2, right? So the probability that box contain exactly 12 plants which produce yellow flower. So probability of X equal to 12. Right. So probability of X equal to 12 should be our N is equal to 20, choose 12. The probability of success 0.55, power of 12, 0.45, power of 8. So this one should be 0. What is the value? The question doesn't not require us to use approximation method. So that one, we can use binomial calculation, or we can use normal approximation. So which one is easiest? Yeah. So we use the easiest one. Why what is the reason we apply a normal approximation? To make sure our calculation easier, right? Compared to if you have n is very large, then to calculate more than or less than, it should be very tedious, right? So then we use a normal approximation. But for this one, it's straightforward. But it depends on the question lah. If the question asks you to use approximation method, then use approximation method. Okay. So B, another garden short cell polyanthus plant in a box of 100. So the short advertisement state that the probability that any polyanthus plant produce pink flower is 0.3. So just now yellow flower, this is pink flower. Use suitable approximation method. So you need to use approximation method, right? So if the question asks you to use approximation method, you need to calculate by approximation method lah. Kalau you use binomial calculation, then you will not get any marks. So find the probability that box contain fewer than 35 plant which produce pink flowers. So let's say this one let note as y having a binomial distribution with n equal to 100 and p equal to 0.3, right? Okay, so we check the condition whether pink it has a binomial problem lah, pink or not pink, right? So NP is equal to 0.3 multiplied with 100 should be 30. NQ 0.7 multiplied with 100, 70. So both are n more than both are more than 5, right? Okay, so then we can use approximation method. So the probability that we want to find is probability of y less than 35. Right? We apply correction for continuity minus 0.5. Y less than 34.5. So probability of Z less than 34.5 minus 30 divided by square root of NPQ 21. Right, so this one should be sorry. Oh, itu jawapan. Okay, right. 0.9819, 0.8365. Okay. You want to take 5-minute rest or continue? Rest 5 minutes, right? So
自己不太知道。它不是跟我在那边，只要是99%，加上你的腰就变成100%，可以吃掉了，吃掉了，100中不会中，很累，做好做满了，那个资料像出来。脸是哭起来了，我的脸。啊，不给了。我是注定了，还想下去，会改哦。就上次那个聊，对啊，这是个，这个我还没完呢。我分，我觉得分的不是适合就分了，是。OK，这样子没有聊，你有没有在选？像我以前男生之前他们有在选嘛？我们是有在房间的在选，然后我跟你讲，已经过2个月了，才选到，厉害的你。认吗？什么？认什么？有话啥好承认的？好不会承认真的。是，我的长称，这就不要。这样有2个都有了，其实。谁就分哦，谁就分哦，对不对？有啊，有啊。其实个节目应该都没过了，那基本上，完全看女生的话，我都笑了。你说这聊很久的，前几天，对对对，对，你看你自己的心理，啊，我，哎，去年的嘛，会是，我还在担心什么？还蛮，就是我可以这样说，对，不要，第一个地方啊，这个，哎，所以你现在是一个人用车，但是你是这样的。嗯，那个是跟八嘛之间，是的，对吧？如果是在这边选择饭店，看前期的，我应该说8.8，是理解，理解，理解到，海南的都 OK，前面的你啊，也是，人家你看去准备，那是我觉得。因为每次就不是问题，大家说为什么？这刚刚女生每个人现在啊，后悔后悔，为我聊我爱，我是为你想猜这个。嗯， 我有了水的，还看低完了，我就水的。这样追的嘞，这个追的嘞，全部是理由。转啊，有机会就有。那个时间不是很有，今天是怎么样啊？那个时间上面有，这上面有的，这边上面有的吧？有懂吗？看到了，看到了，我不想。48跟真有很别哦，你讲好像你这个是一个有那个这样做朋友是有问题的吗？大家都是成年人，哎呦，什么鬼？
Okay, can we continue? Boleh? Can we continue? Right. Let's continue on the next part, which is this is the last part of chapter number 6, normal approximation to Poisson distribution. So still remember the criteria for Poisson distribution. So Poisson distribution takes only count data or rate data, right? And the mean of Poisson distribution is equal to lambda, and variance also equal to lambda, right? Now, so the normal distribution can also be used to approximate the Poisson distribution for large value of lambda, right? So if we have random variable x having a Poisson distribution with lambda parameter and lambda is large, then x can be calculated approximately using normal distribution. And of course, when we want to convert to normal distribution, we need to apply continuity correction and then convert using Z distribution, right? But the condition to apply normal approximation when lambda is large, right? So most of the books, right, will say lambda more than 15 or 20 or 50. Some book will say more than 5. So in our class, we will use threshold lambda more than 5. Right? So we will use lambda more than 5 as our threshold to say that lambda is large. Right? So when we convert to normal distribution, so we know that mean equal to mu, right? Lambda. So sigma square is also equal to lambda, right? So now this is the summary requirement. So when lambda is large, more than 5, x is having a Poisson distribution, we can approximate normal distribution by apply mean equal to lambda, sigma square equal to lambda. And then the most important part is continuity corrections must be applied. Right. Steps are same as previous, but in this condition, we have Poisson distribution. So now let's look at example number 23. So retailer sells television, right? So the number of television sold per week follow Poisson distribution with mean equal to 45. Right? Find the probability that number of television sold in particular week will exceed 60. So here we have lambda equal to 45. Right, so x is number of television sold. We're having a Poisson distribution, lambda equal to 45. So based on our requirement, when lambda is more than 5, we can use normal approximation. We can apply normal approximation. Right. So the first question is, we want to find probability of x more than 60. Right, more than 60. So first step, we apply continuity correction, which is plus 0.5. Probability of x more than 60.5. Right. And then the Z score or Z distribution formula, x minus lambda divided by square root of lambda, right? So this one should be probability of Z more than 60.5 minus 45 divided by square root of 45. So this one probability of Z more than 2.3311. 31 lah, right? So we take 2 decimal point, 31. So this one should be 1 minus probability of Z less than 2.31 equal to 1 minus 0.9896, 0.0104. Okay? Okay? Simple, right? So let's try for B. So how to solve for B? So probability of at least 34, right? And fewer than 50, right? So we plus and plus, so and minus, right? Probability of 30, sorry, you just minus both sides, right? 33.5 x 49.5. Yeah. So probability of 33.5 minus 45 divided by square root of 45. This is Z 49.5 minus 45 divided by square root of 45. So this one should be probability of negative 1.71. Okay, boleh? Very simple. So if you understand the first part tadi, which is binomial problem, so the steps are same, right? So now we have different condition when lambda more than 5. Okay, done. Right, let's look at example 24. Then I think example 25, 26, 27, you can do by yourself. Right, example 25. It is proposed to model the number of people per hour calling for a car breakdown service between time 9 a.m. to 9 p.m. by Poisson distribution. So explain why Poisson distribution may be appropriate for this situation. So you explain lah. We are using the average rate per hour, right? And then the people call may be independent, right? And randomly and consistent, and we have consistent average rate per hour lah. So that is the reason why we have this Poisson distribution is maybe appropriate. So let's look at the second part. People call the car breakdown service on average rate 20 per hour, right? So 20 per hour, this is our lambda equal to 20 per hour. Right? So, and Poisson distribution may be assumed to be suitable model. We want to find the probability that exactly 8 people call in half hours. So means that we want to find probability of X equal to 8, right? 8. And for this condition, our lambda will be 10. right? So can you calculate? What is the formula for Poisson? Exponential lambda negative, exponential negative lambda power of x over x factorial lah. So this one exponential negative 10 power of 8 divided by 8 factorial. So this one should be 0.1125. To 6. Okay. All right. By using suitable approximation, the question asks you to use approximation method. Find the probability that exactly 250 people call in the 12th hour between 9 a.m. to 9 p.m. So we want to find probability of X. So this one kita guna the different random variable. Y equal to 250. Right, so Y is having a Poisson distribution with lambda equal to how much? 240. So 20 per hour multiply with 12 equal to 240. Right? Okay. So when lambda is more than 5, so we can use approximation method lah. Right? So this one should be probability of 250 minus 5 at 0.5, right? So 249.5 until 250 plus 5, 0.5 to 250.5, right? So we know that mean lambda is equal to 240, right? So mean equal to lambda, sigma square also equal to lambda. So probability of 249.5 minus 240 divided by square root of 240. So this one should be probability of 0.61 until 0.68, right? So what is the value? 0.0226, right? Okay. You all okay? Very good. So example number 20 done sudah? 25, 26, 27. I think this is an easy question, so you can do by yourself. Or you want me? You want the answer? Okay. 25 is 0.8438. Right. 26 will be 0.2177. 27, I don't have the answer. Finish dah? Yeah, we finished already.
So much.
But we have exercise until exercise 15. I got 15 question exercise. So this exercise compress yesterday lecture from yesterday and today lah. So you want to see some? Go on. All right. I think hujan dekat luar kan. Nak balik pun tak boleh kan. Tak hujan. Hujan boleh balik. Hello? Tak ada dengar macam hujan. Right. Actually, exercise 1 until 7 until 15 easy question, right? I think should be able to do it. Tak boleh buat means cakap already ya. Okay, I think that's all. Thank you very much.
So next Friday is hybrid.
Hybrid.